we are going to be focusing on equations of linear motion in physics. Before we dive in, as usual, the quote I have today is work is zero when effort does not cause a distance. Yeah, that seems um, that seems like a physics quote. So, and it is very true because even in physics, you have work is equals to force multiplied by distance. Work is multiplied is force times distance. Okay, so if distance is zero, then it means f times zero, that's zero. It means work is equals to zero. So what that is telling us is that even though you make effort, if your effort um, is not causing a distance, then your work is still zero. So such is that about life. If you are pushing something, if you are trying to push something, if whatever you are pushing is not covering a distance, no work is done. And if you are pulling, if whatever you are pulling is not causing a distance, then there's no work that is done. So whether pushing or pulling, there must be a distance covered before we can say work has been done. So such is that about life. No matter the effort that you put in, you must ensure that you are covering distance. Distance means change in position. You must change from one position to another position. You must change from one level to another level. That's why we can say that you have your effort has yielded results. All right. Then we can now say, well done, that you have done the work. Can you imagine a student that has not imagine a student that wants to be promoted. Okay, right now, the class that you are currently, it was because you did exam and you pass the exam, you excel in the exam. That's why you are in the correct class. That means there's a position that you were before, there's a level that you were before, but now you are in a new position, you are in a new level. Why? Because you have done something, you have put in effort, and your effort has covered the distance. That is why you are where you are today. All right. So and that's the same way. If you're going to move from where you are to another position, thereby covering a distance, then you will need to apply an effort that should cause a corresponding distance. Okay? That is physics and it is being applicable to life. So physics is telling you, is giving you insight about life. So let's dive into what we have today. We have equations of linear motion. And today, what I will just do for us is I will show you how to derive these equations of motion. The first one that the first one that we're going to do is that I'm going to be showing you is a acceleration is equals to change in velocity over time. Let's start with that first. Acceleration is equals to change in velocity, meaning that you have final velocity and initial velocity. The velocity it starts with and the velocity that it ends with. Remember, velocity is change is displacement covered by an object per unit time. All right. So final velocity minus initial velocity. That's to tell you that when there is no change in velocity, when velocity is constant, then there will be no acceleration. All right. So change in velocity over time. From here, if you cross multiply, you're going to have v minus u is equals to at. Then finally, we can say v equals u. Then we can say v, if you add u to both sides, you're going to have v minus u plus u is equals to at plus u. So this is going to be v is equals to at plus u, which you can rewrite as v is equals to u plus at. Okay, this is equation one. All right, equation two. To get equation two, all you need to do is you remember that um, for average velocity is average velocity is total displacement. Total total displacement divided by total time. All right, total displacement divided by total time, which can be written as s over t. Likewise, you also remember that um, average velocity can also be average velocity can also be initial velocity plus final velocity divided by 2. Okay, you have this, you have this. So if I equate this to this, we are going to have s over t equals u plus v over 2. So if you cross multiply, this will imply that 2s equals u plus v bracket t. If I divide both sides by 2, so this implies that s is equals to u plus v over 2 multiplied by t. And this is equation 2. All right. So next is equation 3. To get equation 3, you have you already have your equation 1 and equation 2. Now to get equation 3, what I need to do is I can substitute v in equation 1 into equation 2. So equation 2 is s is equals to u plus v over 2 multiplied by t. And since v is equals to u plus at, just say s is equals to u plus at. Remember, we are substituting v from equation 1. All right, let me put it there. Substitute v in substitute v in equation 1 into equation 2. All right, so you have this multiplied by t. So if you cross multiply, no, you don't need to cross multiply it. S is equals to u plus u, that's 2u plus at over 2. Still have t outside there. So s is equals to, let's open the bracket with the t. This will become 2ut plus at squared divided by 2. Alright? So if I split this fraction into 2, I will have 2ut divided by 2 plus at squared divided by 2. So this becomes s is equals to 2 cancel 2. So you have ut plus half at squared. And that is equation 3. And lastly, equation 4. To get your equation 4, you come back to equation 2 again. Equation 2 says s is equals to u plus v over 2 bracket t. Remember from here, t can be v minus u over a from equation 1. So if you cross multiply, you make t the surrogate of the formula, it will become v minus u over a. So we can substitute that here. We can say substitute t in equation 1 into equation 2 into equation 2. Yeah. All right. So s will be equals to u plus v over 2 multiplied by v minus u over a. All right. If you do this multiplication, you're going to have s is equals to u plus v into bracket v minus u over 2a. All right. Now let me show you something. If you remember, you know that if you have difference of 2 squared. Okay, let me just rewrite this. This can also be written as v plus u. All right, v plus u. So either u plus v or v plus u. We are still talking about the same thing. All right. So when you now have an expression like this, do you remember difference of 2 squared? You have a plus b into bracket a minus b. This is the same thing as a squared minus b squared. This is called difference of 2 squared. All right. So if you substitute that here, this is going to give us um, v squared minus u squared over 2a. All right. So finally, sorry, this implies that s is equals to v squared minus u squared over 2a. So finally, I can say that, so if I cross multiply, 2as is equals to v squared minus u squared. So if you rearrange this, so if you add u squared to both sides, you're going to have v squared is equals to u squared plus 2as. And that is equation 4. So those are the 4 equations that we have in under equations of motion, equations of linear motion. So you have v is equals to u plus at, s equals to u plus v over 2 multiplied by t, then s is equals to ut plus half at squared, and v squared is equals to u squared plus 2as. So what is the interpretation of all this? A is acceleration, A is acceleration, U is A is acceleration in meter per second square. What else can we see there? U is initial velocity, V is final velocity, V is final velocity. What else? Both initial and final velocity are in meter per second. So T is time in second. What else? S is displacement, not distance. Okay, because we are dealing with vectors here. So S is displacement. What else have I not mentioned? I think I've mentioned all the parameters, necessary parameters here. So that is that on equations of linear motion. So when you know all this equation of motion, then you can now begin to diversify depending on the conditions that you have. If you have the conditions of motion under gravity, you know that the it can either be against gravity or supporting gravity. That means if I throw this marker up, when it's going up, it's against the gravity, but when it's coming down, it's supporting the gravity. And in those kind of conditions, it's going to alter the value of these parameters. So the significance of all this is that you'll be able to know how each of the equations are derived, so that there will be no need for you to rack your brain when you're trying to recall these equations. All right. So knowing the derivations is has a lot of benefits. So with that, till we meet next time, I remain to Rema. Bye.